Welcome back, Algebra 1 students, to another Regents Review video. This is the August 2015 Algebra 1 Common Core Regents exam. These are going to be the solutions, parts 2 through 4. 2 through 4, that is the short answer and open-ended response question. So this video is going to take just a little bit longer than the multiple choice just because it takes a little bit more time to explain. Okay, here we go. Before we begin, please do not, under any circumstances, cheat using my answers. You have to try the problems on your own. Refrain from cheating. It's time to do your best. Now's the time. Make sure that you hit that subscribe button down below and make sure that you visit my website at www.nysmathreadersprep.com. That link can be found in the description below. And without further ado, and I use the TI Inspire CX, just to let you know. And that link is on my website if you want to purchase it. Without further ado, here we go. Jumping into number 25. Okay, each day Tony records the height of a plant for her science lab. Her data are shown in the table below. The plant continues to grow at a constant daily rate. Write an equation to represent h of n, the height of the plant on the nth day. So just by the instructions saying that it increases at a constant daily rate, you're thinking of a linear function because a line does increase at a constant rate. So remember that the equation of a line is y is equal to mx plus b. Okay? Now notice, folks, that these are increasing by plus 1.5 each individual time. So your equation is h of n is equal to 1.5, which is the slope n, plus the y-intercept. Now, it doesn't tell you what your y-intercept is here. Your y-intercept is the value of y where x is equal to 0. But they don't tell you what the 0 is. But you know that if it's increased by 1.5, just go 1.5 less, and then you get 1.5. So this answer is perfectly acceptable. H of n is equal to 1.5 n plus 1.5. That's acceptable. Or you could also say h of n is equal to 1.5 times n minus 1 plus the number 3. Either one of those answers is perfectly acceptable to get this question right. All right, moving on to number 26. On the set of axes below, graph the inequality 2x plus y is greater than 1. So what I'm going to do first is I'm going to subtract the 2x on both sides. You then get y is greater than negative 2x plus 1. Let's talk about this for a moment here. Well, we know that the slope is negative 2. We know that the y-intercept is the point 0, 1. We also know that this is going to be a dotted line. And we also know that it is your shading above because it is greater than. So from here, what we're going to do is we're just going to basically graph this. So the slope of negative, so it starts off at 0, 1, and you're going down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and you keep on going. And then in reverse, you just go up 2 to the left 1, and you just keep on going. Now from here, all you do is you just take a line. In this case, I do have a nice dotted line here. And what you do is you just connect all of these points, and it has to be dotted because it is greater than, so it does have to be dotted. And we are shading above, like that, and just label 2x plus y is greater than 1. You are done with that question. All right. 27. Rachel and Mark were given the information shown below about the bacteria growing in a petri dish in their biology class. Rachel wants to model this information with a linear function. Mark wants to model it using an exponential function. Which model is a better choice, and explain why you chose this model? Okay, remember that linear function is you're increasing at a constant rate. Is this function increasing at a constant rate? Is that most appropriate? Well, look here. We're increasing by 60. Then we're increasing by 70. Then we're increasing by 90. Then by 110. Then by 140. That doesn't look like a line. So Rachel is mistaken. So which model is the better choice? We are going to say that exponential, which if you want to say that this is Mark's choice, that's fine. Oops. Mars choice. Mark's choice. Because b of x, which is the function that we're talking about, b of x does not grow at a constant rate. All right. Now, if you wanted to just explain yourself a little bit more, you could just say, meaning that slope is not the same at each interval. All right. And that's how you explain that. So Rachel's wrong, Mark is right. Okay, cool. 28. A driver leaves home for a business trip and drives at a constant speed of 60 miles per hour for 2 hours. He then gets a flat tire and spends 30 minutes changing that tire. She then resumes driving and drives at 30 miles per hour for the remaining 1 hour until she reaches her destination. On the set of axes below, draw a graph that models the driver's distance from home. Okay, so I'm going to make this a little bit bigger. So, she's driving 60 miles an hour for 2 hours. Now, notice this. This shows distance on the left-hand side, and then time is on the bottom. So, if she's driving 60 miles an hour, what that means is she's going 60 miles in 1 hour. Now, if she's driving that speed for 2 hours, that means that she travels 120 miles in 2 hours. Because if you just do 60 over, well, if you just do 1 hour, she travels 60 miles, and then an additional hour, she traveled another 60 miles, so that means that she traveled 120 miles in 2 hours. Okay? So what I'm going to do here is I'm just going to draw a line just like this. Oops. I want it solid. There we go. Okay, just like that. So this is her driving at 60 miles an hour. Then she gets a flat tire and spends 30 minutes changing the tire. Now notice the interval here. This is from 2 to 3 hours. And each individual line shows a half. So she changes it for 30 minutes. You should know that there are 30 minutes is equivalent to 1/2 hour. So this section right here is her fixing the flat tire. Then she resumes her driving and drives 30 miles per hour. So if she's driving 30 miles per hour, she's just going from 120 to 150 in 1 additional hour. So we're stopping right here at 3 hours and 30 minutes. So once again, this is showing driving at 60 miles per hour. This interval shows the flat tire for 30 minutes. And then this interval over here shows driving at 30 miles per hour. And that's it. Pretty simple stuff. Moving on to question 29. How many real solutions does this equation have? Justify your answer. Now, I personally found this question to be quite interesting. How many real solutions? I don't think that many algebra students learn this, but if you did, that's fantastic. If you didn't, you learned something new today. Oops, I just totally butchered that spelling. This is called, okay, that is a horrible way of spelling that. Discriminant. Did you students learn the discriminant in Algebra 1? I don't think you did. Discriminant's kind of taught in Algebra 2, but this is what the discriminant is if you don't know what it is. The discriminant describes the nature of the roots. Okay? It describes the nature of the roots. So, let me just tell you a couple facts. If you're now, okay, real quick, the discriminant formula. So the formula, I do need to tell you the formula. The formula for the discriminant is b squared minus 4ac. If this looks familiar, it should be. In the quadratic formula, x equals negative b plus minus the square root of b squared minus 4ac. So this is underneath the radical of the quadratic formula. Now, listen, I'm not going to go in depth as to why you use this formula. I'm just going to tell you to use it. I promise you this, you are going to learn why you use this formula when you get to Algebra 2. It's just too advanced to talk about right now. You'll learn in mathematics later in life that there are things called imaginary solutions or imaginary units. Again, you'll learn that in Algebra 2, not right now. So, but if you want to learn more about it, by all means Google it, or just watch my Algebra 2 videos and you'll see it there. But the formula is b squared minus 4ac. So if the discriminant, which is b squared minus 4ac, is less than 0, meaning that it's negative, this produces no real solutions. If the discriminant b squared minus 4ac is greater than or equal to 0, this does produce real solutions. Okay? So all I have to do is I just take my discriminant, which is, again, b squared minus 4ac, and I just say, all right, my a value is 1, my b value is negative 2, and my c value is 5, based off of my equation up here. And you just plug it in. So we get negative 2 squared minus 4 times a, which is 1, times c, which is 5. Then you get 4 minus 20, and you get negative 16. So, since the discriminant is negative, you are going to say no real solutions because the discriminant is negative. So I just ask all of you to really just copy this information down onto your sheet, page, whatever you're working with, and just memorize those facts. I promise you that you are going to understand why this is the way it is in Algebra 2 when you get to it. All right? Or if you want to Google it, by all means. Or better yet, if you want to impress me, send me an email and I'll explain why it is the way it is and why the discriminant, if it's negative, it produces no real solutions. I'll be happy to explain it to you over an email. So either do that or you could even write in the comments below. I'll be happy to answer it. Number 30. The number of carbon atoms in a fossil is given by the function y equals 5,100 times 0.95 raised to the x, where x represents the number of years since being discovered. What is the percent of change each year? Explain how you arrived at your answer. So, make sure that you drill this formula into your head. A of t is equal to the principal times 1 plus or minus the rate raised to the t power. This, ladies and gentlemen, is what we need. Because this is in the form of that right there. It's asking you what is the percent of change. This, inside these parentheses, represents the percent of change. So what we're going to do here is we're just going to take 1 minus r and set it equal to 0.95. Now, why am I picking minus? Well, this number 0.95 is less than the number 1. That shows exponential decay. So this is a decay function. Okay? So it is decreasing. So it's 1 minus the rate is equal to 0.95. Now let's just continue to solve. So minus 1 on both sides. You get negative r is equal to negative 0.05. Divide by negative 1 on both sides, and you get r is equal to 0.05. Now it's asking you the percent of change. This is a percent expressed as a decimal. So your answer is going to be the percent of change each year is 5%. You have to convert that to a percent, by moving the decimal point 2 places to the right to get 5%. All right? Now, it does say explain how you arrived at your answer. So I'm going to say to find this, subtract 0.95 from 1 to get the percentage expressed as a decimal. Then convert. And that is your answer. All right, moving on to question 31. 31. Okay. A toy rocket is launched from the ground straight upward. The height of the rocket above the ground in feet is given by the equation h of t equals negative 16t squared plus 64t, where t is the time in seconds. Determine the domain for this function in the given context. Explain your reasoning. So look, your t value is the domain. T is the time in seconds. So it says determine the domain. You actually have to solve for t. So negative 16t squared plus 64t, you're going to set this equal to 0. Okay? So now from here, negative 16, now, I could actually take out a GCF. You could take out a negative 16 because 16 goes into both 16 and 64. And you could also pull out a t. And you get t minus 4. Set it equal to 0. Then you t-bar it. T is equal to 0, and then t is equal to 4. By the way, I got this negative 16t. You just set negative 16t equal to 0. Divide by negative 16 on both sides, and you get t is equal to 0. So these are your numbers that you have. Now, they're asking you to state the domain. So the domain is 0 is less than or equal to t, which is less than or equal to the number 4. That is your answer. And then it says explain your reasoning. But what does that really tell you? Well, this domain tells us that the toy rocket launches at time t equals 0 and lands at time t equals 4. Now remember that this is a toy rocket, so it's being launched at 0 seconds and then it's landing on the ground at 4 seconds. So that is going to be your answer. All right, moving along. 32. Jackson is starting an exercise program. The first day, he will spend 30 minutes on a treadmill. He will then increase time on the treadmill by 2 minutes each day. Write an equation for t of d, the time in minutes on a treadmill on day d. So what you need to write down is t of d is equal to this. Now, it says on the first day he spends 30 minutes. So there's his first day, 30 minutes. Plus, now he's increasing it by 2 minutes each day. So it's going to be 2 minutes times the amount of days minus 1. Now remember, that's coming back again. That minus 1 is taken into account that is the first 30 minutes on day 1. Because if you leave it as 2D, that means that he ran 32 minutes on the first day. You have to take into account that you have to subtract the first day. You could write it as this, which I don't like, or you could write it as how I like it. T of d is equal to 2d plus 28, meaning that if you plug in the number 1 on the first day, that amounts to 30, and then if you plug in 2, then it amounts to like 32, and it keeps on going up. So either one of these is perfectly acceptable. Then it says find t of 6, the minutes he will spend on the treadmill on day 6. So all you need to do is you need to take the 6 and you need to plug it into one of those formulas that I have up there. So since I assume that most of you wrote down this up here, I'm going to use that one. So t of 6 is equal to 2 times 6 minus 1 plus 30. So t of 6 is equal to 2 times 5 plus 30. 2 times 5 is 10 plus 30. And that is equal to 40. So he ran 40 minutes on day 6. And that is your answer. We are all done with the part 2s. Now we're going to move on to the part 3s, and they are a little bit more in depth. Okay. Graph f of x equals x squared and g of x equals 2 raised to the x for x is greater than or equal to 0 on the set of axes below. So I am not going to graph these on the calculator. It is your job to graph these yourself. Actually, you know what? Forget it. I should graph it just because I know that there's going to be a follow-up question that asks me about something. So I'm going to do that right now. So I'm going to go to my graph, x squared, and then 2 raised to the x power, and I get that. All right, fine. Now, if you press Control T, you get your table of values. It is your job to copy that on your exam. So f of x, I'm going to write down x and y, and I'm going to go ahead and write that down. So here is my table of values. So I get 0, 1, 2, and 3. Your values are 0, 1, 4, and 9. G of x over here, which is x and y, is 0, 1, 2, and 3, 1, 2, 4, and 8. Now, the reason why I'm stopping at 3 is that if you go back to your graph and you label this, this is 1, 2, 3, 4, 5, and I'm labeling over here as 1, 2, so I'm skipping lines here. So 3, 4, 5, 6, 7, 8, 9, and 10. So they're just asking you to graph it. Just a basic graph. Not too bad. You could stop wherever you want. It doesn't matter. Okay? So I'm gonna go 0, 0 for the blue. 1, 1, 2, 4, and 3, 9. Notice why I stopped where I stopped, because it increases extremely quickly. So this blue function is f of x. Now, g of x, let's see, 0, 1, 1, 2, 2, 4. Ooh, they intersected that point. They might ask a question about that. And then go up to 3, 8. 3, 8? Yes. Okay. So now I'm just going to draw that graph like this. Okay, like that. So, and I'm going to label that as g of x. Perfect. So that's fine. And then it asks us a follow-up question. State which function, f of x or g of x, has a greater value when x equals 20. Justify your answer. So what your job is first of all, 20 is not even on the graph. So you actually have to figure this out algebraically. Well, they told you what f of x is, and they told you what g of x is. Let's figure it out. So if I plug in f of 20, that is equal to 20 squared. If you take 20 and you square it, what does that give you? 400. So we get 400. Now, if you take g of 20, that gives you 2 raised to the 20th power. Well, 2 raised to the 20th power is that number, 1,048,576. So 1,048,576. So, of course, you have to say g of x because 2 squared, sorry, not 2 squared, 2 raised to the 20th power is greater than 20 squared. And that would be your justification, and that's it. Or you could just look at the table of values. If you go down to 20, notice how the blue is a lot less than the red. So that's how, I mean, I don't think that you can say I just graphed it and then that's it. I think that you do have to explain it a little bit of an algebraic way. All right, number 34. Solve for x algebraically. All right, let's do it. Distribute that -3, and I'm going to combine the 6x and the -9x on that side. So we get 7x minus 12x plus 24 is less than or equal to -3x plus 12. The 7x and the -12x combines to -5x plus 24 is less than or equal to -3x plus 12. So now what I'm going to do is I'm going to add the 5x on both sides. Whoops. That is a horrible x. So now we get 24 is less than or equal to 2x plus 12. Now we're going to subtract the 12 on both sides. We now get 12 is less than or equal to 2x. Divide by 2 on both sides, and we get 6 is less than or equal to x. Oops. 6 is less than or equal to x, which is just the same thing as saying x is greater than or equal to 6. Make sure that you know both ways on how to write it. Then it says, if x is a number on the interval from 4 to 8, state all integers that satisfy the given inequality. Explain how you determine these values. So if x is greater than 6 and it stops at 8, meaning you could have the integers 4, 5, 6, 7, 8. But if x has to be greater than 6, your integers are 6, 7, and you stop at 8. Okay? So that's your answer. 6, 7, and 8 are the integers. Because these are the numbers, or sorry, I should say integers, because these are the integers that are greater than or equal to 6. And that is it. That's how you do it. You are all done. Entire page. There we go. Okay. 35. Let me change the pen color here. Ooh, nice maroon. All right, 35. The volume of a large can of tuna fish can be calculated using the formula V equals pi r squared times the height. Write an equation to find the radius r in terms of V and h. So your job is to find r. So V equals pi r squared times the height. You're going to divide by pi and h on both sides. Pi's cancel, h's cancel. You get r squared is equal to v over pi h. Now take the square root of both sides, and then you get r is equal to the square root of v over pi h with a plus minus out front. Okay? That's your answer. And then it says determine the diameter to the nearest inch of a large can of tuna fish that has a volume of 66 and a height of 3.3 inches. So what that means here is it should be buzzing around into your head that you have to take your formula, which is r equals the square root of v over pi h, and plug in v is equal to 66 and h is equal to 3.3. So your radius is equal to the square root of 66 over pi times 3.3. Okay? When you plug that into your calculator, you get the square root, control division, 66 over pi times 3.3. 2.523. Now read the question, though. Determine the diameter. I hope that you have some little mathematical background when you were in middle school, possibly, to understand that the diameter is double the radius. So all you need to do is multiply that number by the number 2. So multiply that number by 2. Your diameter is approximately equal to 5. That's to the nearest whole number. So your diameter is approximately equal to the number 5. And that is your answer. All right, 36. Chugging away here. Here we go. 36 says the table below shows the attendance at a museum in select years from 2007 to 2013. State the linear regression equation represented by the data table when x equals, oh boy, this is important. When x equals 0 is used to represent the year 2007. So this means that this is x equals 0, x equals 1, x equals 2, x equals 4. Be careful because it skips 2010. And x is equal to 6. Be careful again, it skipped 2012. So what I'm going to do is I'm going to take this information and I'm going to go right to my calculator and I'm going to go to data and, listen spreadsheets. So this is my year and this is my attendance in millions. So I'm going to type this in. So 0, 1, 2, 4, and 6. Now these numbers are 8.3, 8.5, 8.5, 8.8. Looks like we have some learners here. If they're visiting a museum, lots of people who want to learn. Alrighty, so now what I'm going to do is I'm just going to press Control Doc, add a calculator go to Menu, Statistics, Stat Calculations, and we're doing Linear Regression. Click on MX plus B. All right, now you're going to click on Year and Attendance. Click OK. We are looking specifically at M and B, and if we want to include R, that's perfectly fine as well. They might ask us a question on the correlation coefficient. So what your job is on the Regents is to actually copy that table down onto your paper. So I'm going to put it right over here. So I'm going to put title, linear regression. Okay. Then you just need M, you need a B, and you need an R. You don't need all that other stuff. You don't need those. But you want to write title linear regression just to show, hey, you know, I'm using a line here. Okay? So now what we get is we get M is equal to 0.1577. Then we get B equals 8.2698. And we get R is equal to 0.9745. Okay. So now your linear equation rounded to the nearest hundredth is going to be y is equal to mx plus b. Remember that's your standard form of a line. Y is equal to, well, let's see, 0.16. Round that up. X plus 8.2, rounded up again, 7. Ladies and gentlemen, that is your equation to represent this. Y is equal to 0.16x plus 8.27. That is the equation of a line, of this line. Now, the follow-up question says, state the correlation coefficient to the nearest hundredth and determine whether the data is a strong or a weak association. Well, obviously, the correlation coefficient is strong, or sorry, the correlation is strong because the correlation coefficient is close to the number 1. It's 0.97. So you're going to say in your answer that the correlation coefficient is R equals 0.97 rounded to the nearest hundredth, which shows that the line of best fit is a strong association. Happy. And that's how you explain your reasoning. Not too bad of a question. All right. The part 4 is a little difficult, but we are, of course, going to get through it. All right. 37. Here we go. And it says that a rectangular picture measures 6 inches by 8 inches. Stop right there. Draw yourself a picture frame just to have an idea of what's going on. So I'm going to draw myself a picture frame. Looks like that. And it is 6 inches by 8 inches. It doesn't have to be drawn to scale. But Simon then wants to build a wooden frame for the picture so that the frame picture takes up a maximum of 100 square inches on his wall. So that means that he has a picture and he wants to just put it into a frame. So the frame could look like this. That could be his picture frame right there. Actually, you know what? Let me draw a little bit to scale. It needs to be the same all throughout. Let me try that again. Okay. That could be his picture frame. So if you see here that, let me just, I don't know, most picture frames could be brown. So this brown shaded region that you see here, this is the frame itself, and inside this is the picture. So, I don't know, you could draw a little me in here. So here's the little, there's me, Trevor, with the little red hair, you know. All right, so that's me, and I don't know, I'm at my desk with my computer teaching you guys math. As you can see, I'm not an artist. So, it says here that this is 6 inches by 8 inches. So this picture is 6 by 8. Now, do we know the distance from here to here or from here to here on the picture frame? If I zoom in a lot, do we know the distance from, again, from here to here or from here to here? No, we do not. So what I'm going to do is I'm going to call that X and X. And the reason why is this. The length of the picture is going to be represented by 6, which is the length of the picture, plus 2 x's. And the height is going to be represented by 8 plus 2 more x's, because this is x and this is x. And the reason why I know that is that they specifically tell me that the pieces of wood that he used has the same width. So that's x, 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 and x. So write an equation or inequality that could be used to represent or determine the maximum width of the pieces of wood for the frame that Simon could use. So I said, first and foremost, that the area of a rectangle is just length times width. So the area is equal to 2x plus 6, 2x plus 8. Now, it says here that it has a maximum area of 100. So it could be 100 or it could be less than that. So my equation that I wrote is just 2x plus 6, 2x plus 8 is less than or equal to 100. Now, could you write 2x plus 6, 2x plus 8 is equal to 100? Absolutely you can. It could be equal to 100. But you could write this, or you could have wrote 2x plus 6, 2x plus 8 is equal to 100. Either one of those would be perfectly acceptable on the exam. Now, then it says explain how your equation or inequality models this situation. So, I said that this inequality slash equation. Well, actually, you know what? I'm just going to use inequality just because that's what I wrote on my answer key here. But if you wrote equation, then it just changed a little differently. But this inequality is determined by the idea of maximizing, because you're maximizing the area. The frame can be 100 square units, or sorry, square inches in area, or less than that. So a less than or equal to sign was used. Okay? Now we could say I added the two parts that are the unknowns to both the length and width. And that would just be explaining what the situation models. Then it says solve the equation or inequality to determine the maximum width of the pieces of wood used for the frame to the nearest tenth of an inch. Here we go. So we have 2x plus 6, 2x plus 8. That's less than or equal to 100. I'm going to distribute these. We then get 4x squared plus 16x plus 12x plus 48 is less than or equal to 100. Combine like terms, you get 4x squared plus 28x minus 52, and that is now less than or equal to the number 0. Now from here, we need to use the quadratic formula. X is equal to negative 28 plus minus the square root of b squared. So 28 squared is 784 plus, because 4 times a, which is 4, times c, which is negative 52. So that gives you positive 832 all over 2 times 4, which is going to be 8. So I'm going to plug this into my calculator. Control division. Negative 28 plus the square root of 784 plus 832, all divided by 8. We get an answer of 1.5. Now, just to make sure, if you put this as minus, it should give you, yeah, so you can't have negative width. So it has to be 1.5. So we're going to say that the maximum width, now they're saying what, round to the nearest tenth? Yeah, the maximum width is 1.5 inches. And that, ladies and gentlemen, is how you do that part 4 question. Honestly, that was a challenge if you didn't know how to draw that diagram. But if you draw the diagram, it makes it that much easier, does it not? Okay, that is the conclusion of this video. Make sure that you hit that subscribe button down below, and please please visit my website at www.nysmathregisprep.com for more math preparation algebra 1 as well as future math subjects, and I hope to see you soon.